Okay, so in order to identify the domain and the range of the inverse function, just remember that the inverse function and the original function are essentially opposites of each other. So the domain of f inverse is equal to the same thing as the, I'm going to use a vertical equals if that's okay, it's equal to the range of the original f. Why is that? Because the domain of f inverse represents the set of x's that are valid. Okay, and however, the input, that means the set of inputs, but the input of the inverse is the same as the output, or y values, for the original function. Okay, so the y's are outputs, these are outputs, for the original function is the same as the inputs of the inverse function. And the same thing with range, okay, it's the same kind of idea. So for the range, same idea. So the range of the inverse function is the same thing as the domain of the original function. Okay, for basically the same reason. We're switching x and y. We're switching the role of input and output. Okay, so inputs of the domain, inputs or domain of the inverse is the same as the outputs or range of the original, and vice versa. The range or outputs for f inverse is the same as the inputs of the original function. Okay, so in order to determine the domain and range of the inverse, we don't actually even need to determine the formula for the inverse. We can just work off the formula for the original function and remember the fact that domain and range switch roles, okay, between the original function and the inverse function. So they're already giving me the domain of the original. Now this is not the full domain. This is what's called a restricted domain. They're saying we're going to restrict this function to the region between -5 and -1. Okay, so this is what's called a restricted domain, but it's still a domain. It's some x's that we're going to use, okay? So it's a restricted domain, but still, it's what they want us to use, okay? For f. Okay, whoops, that's for the original function. Now, the next question is, how do we use that to figure out the range of the inverse function? The answer is there's no work to do, okay? That's automatically going to be the range of the inverse function. Okay, so the range of the inverse function is the same as the domain of the original. And of course, we can write that in inequality notation, -5 less than or equal to x, less than or equal to -1, or in interval notation, -5, comma, -1, using square brackets because we're allowed to be equal to the endpoints. Okay, if we had to stop just before the endpoints, we would use round brackets. Now, the next question is, the more difficult thing is, the range of the inverse function is easy because it's the domain of the original. But what about the domain of the inverse function? Okay, so remember the domain of the inverse function, domain of f inverse, is the same thing as the range of the original. So I need to know the range of the original. Now what is my original function? My original function was f of x is, in the case we have here, 6x squared plus 60x plus 158. Now you should recognize that as a quadratic function. It's got an x squared in it. The highest power is power 2, so it's a quadratic function. So a quadratic function will graph as a parabola, and it's going to be a parabola opening upwards because I have a positive number in front of the x squared. So it's going to be an upward parabola. So if I draw myself an upward parabola, well, the question is, where does the parabola kind of bottom out? Where's the vertex? I know it's an upward parabola, so it's going to look like a smile, kind of like a U-shaped picture or graph. The question is, where's the vertex? Where's the turning point? Where's the parabola turn around? And so to locate the vertex, we can use the fact that this is called the A coefficient, is 6 in this case, my B is 60, and my C is 158. And we know that the vertex of a parabola is at x equals negative of the B coefficient over 2 times the A coefficient. So in our case, it's going to be negative of 60 over 2 times 6, which would be negative 60 over 12, which is what? Negative 5. Okay, so the parabola is going to bottom out at negative 5. Okay, so if I go to negative 5, right, I know the parabola is going to bottom out there and go up on both sides. Okay. So, okay, also note that we're really just going between -5 and -1 with this parabola because they told us to restrict to that domain. So I'm really just caring about this portion of the parabola from here to here. It continues here, and in fact, I probably shouldn't have drawn the entire thing because we don't need this part of it. Okay, mathematically, yes, the parabola does continue here. It kind of turns around at the vertex and goes back up again. But we only care about this portion of it because that's what they told us to look at. Between -5 and -1 on the x-axis. So these are the points on the graph corresponding to those x values. Okay, so the range of the original function, so the domain of the inverse, which we're trying to find, is the same as the range or y values of the original. So if I could figure out these y values, like what is this y value right here and this, the lowest and the highest y values that I'm seeing, this would be the range of the original function. Okay, so how do I do that? Well, one way to do it is just to kind of realize, hey, my turning point on this parabola is down here. That's the lowest point, that's the vertex. And so if I could just figure out the height there and figure out the height at -1, all the values between those y values will be accessible by this function. That'll be my range. Okay, so I can just go onto my calculator and figure out what is f of -5 and f of -1. Okay, now a fast way to do that, and also just another way to do this problem, is to use a graphing calculator. Not everybody has a graphing calculator, but if you do, it's kind of handy. Okay, I'll show you how to use that. Okay, so I brought up a picture of a TI-84 onto the screen. So a fast way to do this is go to the y equals menu and enter your function. Okay, so my function was 6x, which is right here, squared, plus 60x. So I'm just typing in the commands. Plus 158. Enter. Okay, there's my function. And now I could get a graph, but actually I'm more interested in a table. A table is just a fast way to access the data. So first I'm going to go to table set, make sure my table is set up correctly. So I'm going to hit second function. Right above window is table set. And I want to have this is what's called a standard table, starting at 0. Delta table means how much do you jump, like what does the x change by every row from row to row. Usually we set that at 1. And we leave the independent and dependent both on auto. That means that the calculator will set up the table for us. We don't have to type in the x's if we don't want to. Okay, and so now let's go ahead and make a table. So right above the graph button is table. And I'm just interested in, so I'm going to scroll up here so I can see what's going on at -5. So I over-scrolled. Sorry about that. The emulator here is a little slow to respond. Okay, let's get everything on screen that we need. So at -5, I see the height is 8. Right, see it right here. Okay, and at -1, I see the height is 104. So from 8 up to 104. So let's go back and label that. Okay, so this height here is 104, and this height here is 8. So that's my range. Okay, so the range of f of x is from 8 through 104. Now, are they rounded? Whoops, 104. Sorry about that. Are they rounded brackets or square brackets? What should we use? Rounded or square? Let me write that a little clearer. Sorry about that. From 8 to 104. Okay. Rounded or square? Well, can I stand right at this vertex? Yes. So then I can stand right at a height of 8. So 8 is included, square bracket. Can I actually hit a height of 104? Yes, since I can hit -1. Am I allowed to be at -1? Yes, I am, because I'm allowed to be equal to -1. So I can stand right at -1. If I'm standing right at -1, I'm right on this point, which means my height is 104. So 104 is included, 8 is included, so that's why there's square brackets there. So that's the range or set of y values for the original function. That's going to be the domain of the inverse. Okay? So the domain of the inverse is the same as the range of the original. Okay, which is the set of y values, which is what we just found. Now, of course, if you don't have a graphing calculator, you can sort of do the same thing just by typing in, just do the computation sort of, 6 times -5 squared plus 60 times -5 plus 158 on your calculator, and same idea here, 6 times -1 squared plus 60 times -1 plus 158. So just do these on your regular sort of scientific calculator, and you'll get your range. Now, It helps to know that the function's sort of behaving in this way, but I could know that just by knowing where the vertex is. If I know the vertex is at -5, that's going to be and it's an upward parabola, which it is, because we have a positive coefficient on the x squared, that vertex will be the lowest point, and the function can only go up higher and higher from there. Okay? So I know this is my range from 8 to 104, so then that's the domain of the inverse. Okay? We could also graph the function just to prove that this is the correct graph, but to do that we're going to have to change the window. Okay, so if I just bring up the calculator again real fast, just so we can verify the graph, I'm going to hit the window button. Notice the standard window is from -10 to 10 on the x's and -10 to 10 on the y's. That's not going to work in the y direction. First of all, in the x direction, I don't really need -10 to 10. I really only need like -10. Actually, I don't even need that. I'll just go like -6 to 0 in this case, because they only want me to go between -5 and -1. So I'll just extend that a little bit. Whoops, sorry, I made that disappear. I'll just extend the window a little bit on both sides. So I'll go to -6 and 0. What about in the y direction? Well, I don't really even need to go to -10. I can just start at a height of 0 if I want for the y direction. So for my y min, I'll start that at 0. And I'll go up to, I better go up past 104. I'll go up to about 150. You always want to go a little bit past your biggest point. And then notice the scale. The scale represents how much each little hash mark in the graph represents. So if I'm trying to go between 0 and 150, the calculator is going to try and put 150 hash marks in there, and it can't do that. So I'll just make each hash mark worth like 10. You don't have to change this if you don't want to, but it makes it a little bit prettier of a graph. This way I'm only going to get 15 little hash marks between here. Okay? So now let's hit the graph button, and we should see what we expected, which is down here at this vertex, our height's going to be at a height of 8 right here. And then as we go up, 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 once we hit -1, which would be here, we should have a height of 104. Okay? We could even use trace to check it if we wanted to. Okay, so notice, now trace is not perfect because it goes in little increments. It doesn't necessarily stop where you want it to stop. But it's a good idea just to kind of look at things. So if I go to -5, or very close to -5, I'm seeing my height is 8. And if I trace through to -1, we should see a 104. So I'll try and get to -1. We'll see if the trace will let me. There we go. And I'm getting to a height of 104. Okay, so that proves that we have the correct graph, so we have the correct range of the function, which means we have the correct domain of the inverse function. Okay, and there we go.